Okay, let's begin our, continue, I guess, our look at that extended crop model. We started with it at the end of our discussion of parametric programming, and we are going to do some parametric programming on input choice. But first, we're going to think about how to build out this model with some detail that may be important for trying to think about what a labor demand or a land demand equation or representation should look like. So this one is about modeling labor types in the farm model. We'll call this a lab because when you get to the last side, you'll see there's some requirements for submission, a few experiments I want you to run and bring to class. I'll put together a document that's there as well, but get you some specs. But the main thing is bringing something to class with you that has your notes for the questions. We're going to talk about those questions. Put your name on it so that you can hand it to me. Okay, so those questions are on the last slide, and I'll introduce those questions and talk through them. That's why I didn't just make a handout, because I wanted to be sure that that I didn't forget to look at the setup just a bit before exiting this lab. Okay, so Kaiser and Messer, Chapter 4 is really about expanding the farm business model. So we haven't read that book completely faithfully, but if you go through there, it's sort of three chapters sort of setting up just what can you get out of this, sort of our midterm material. And then Chapter 4 is about sort of expanding these models to things that aren't convenient for us to do with pencil and paper, to really sort of promote the idea that computer models are going to be important for us. And then if you look at the next three chapters, it's about some parametric programming. How do you sort of do policy analysis or business or decision analysis in these type models? How do you sort of incorporate uncertainty and think about how you might deal with risky decision making in these models? And so those are the topics we'll get to think about. And as we build out this sort of disaggregate or detailed farm model, we'll talk about why these details are important to be able to think about these sort of more broad questions. And so the objectives, I think, that are in there so this is some combination of their objectives and me adding to it. So illustrate disaggregated decision models. Think about the linkage between input choice and output choice. So we have not been as careful as we might have been in that, mostly because we wanted the models to be things we could solve by hand, put together in a reasonably sized tableau, or be able to graph things even. That's great. That's a great way to learn. And now we're going to put a bunch of details in. Think about how you sort of get a single model that has all these linkages in it, and then how do you work around that into blocks and think about using the same analytical tools, thinking about the shadow prices, the reduced cost, or that objective penalty. How do you go back through that and explain things and think about alternatives? So we do have these sort of stages of production, which may be important. It could be very important for policy constraints, for example. And then parametric programming is the topic we've introduced, and we'll return back to it to think about what kind of functions are generated out of these programs, these detailed models. And some other things here, uncover the data underpinnings. So we get a result, we get a linear programming or sensitivity type result. Can we trace it back? Can we trace it back to the data assumptions? And that means that's important, because that gives us a way of thinking about the parametric programming or the type of demand function we might be generating, and how it might look, and why it might take the shape it does, right? So there's just no substitute for being able to trace quantitative results to quantitative assumptions. And certainly the last piece here, uncertainty is a big is a big modeling issue. We do sensitivity analysis for sure, but what if we wanted to think about not parameters that are assumed to be known, but they are known in terms of their distribution. So we know something about the expected value and a little bit about the dispersion or the expected dispersion, a couple of moments of the distribution, and how does that affect our decision making, whether we're before we even begin thinking about risk attitudes. Okay. So the focus on labor here is interesting enough. We're going to talk about labor types in one specific case, just family labor versus labor that is hired onto the farm. But these type of models are increasingly valuable for things like migration policy, where it is being decided, or sort of we're seeing shifts in the way migration is being handled and on farms. And farming and agriculture are a place where a lot of undocumented labor is employed, and changes in the way that sort of undocumented labor is handled, whether it's by bringing in more seasonal work through the documentation system, through the visiting visa program, or deportations, or however you want to think about it. I mean, this is a place where knowing the alternatives that exist is going to be important for understanding the economic implications for production agriculture. Okay, so if we're going to have the idea of being a detailed model, then we need some detailed information, and that's there in Chapter 4. So I gave out a handout already that has this data proposed in the form of budgets, and we'll come back to that when we actually build out the full model. But I do want to just cover what they have in the chapter there. So if you put this bracket around here, there must be a reason. And it's because these are the crop-specific sort of production and harvest activities. And so we're talking about stages of production. Prior to that, we have something we call the land preparation phase. And since the costs and the labor, the dollars per acre and the hours per acre in plowing and disking, it doesn't matter if you're doing that plowing and disking in preparation for planting corn, soybeans, or wheat, then we could consider that to be a generic activity. And so over here you can see that I come up with these categories, so crop generic, crop specific. And then you move on from there. Hired labor is just a labor unit that you want, right there it is, a labor unit that you want to bring on to the to use. It has a $6 cost. We have some corn price and yield, soybean price and yield, and wheat price and yield assumptions. So that's how we would pick up the revenue. And they just make a note here. This is old information, so don't worry about it too much. Trying to find it in the latest futures market pricing, or wherever you might look, or the yields either. But what is interesting is, I bet if you go and compare the soybean to corn price ratio, or the soybean to wheat price ratio, they probably aren't too far off, because the relative value of those things tends to hold, because they tend to compete for the same land. So the scarcity doesn't. If one becomes relatively scarce, there's a high demand shift. Well, shifting a bunch of output into that crop tends to balance those back out, so that the price ratios hold. Okay, so I think I'd already mentioned in class that we're going to first build this model in aggregate, and then we'll use that aggregate version of the model to play around with the labor side of the model just a little bit. And then when we come back to class on Thursday in class, we'll compare we'll build the disaggregate model and compare the results of the two sort of core considerations. But we're going to do this divergence into labor so that we get a feel for the construction of a hiring and selling activity. And that is our goal here. We are going to think about what does it mean to hire labor? And if we're hiring labor as a substitute for on-farm labor by the family, and if we're going to hire labor in, should we consider, as a substitute, should we consider the possibility of working off-farm or selling the family labor to the market at some rate? And so those are what we'll talk through. Okay, so they in the chapter they talk about constructing a model with these coefficients based on the budget information or the assumptions on the previous page. So here we would have the corn coefficient in the objective equation, the soybean and the wheat coefficients, all from the objective equation. So the first piece here is the revenue assumption. So price times yield all the way down. And then the second piece is the full variable cost of production. So the plowing cost, the disc cost, the planting cost, and the harvest cost. These are the variable costs. We do not include here the labor because when we look at that last page, we see that the hire labor is a choice. It's a choice in the model. And so there's some labor available to the farm already, and there's some ability to hire labor in. And so that cost is going to be handled directly through the choice set of the model, and therefore it doesn't belong. It's going to have its own objective equation coefficient. It does not belong in these costs. So these are the full variable costs of production, the labor. Maybe that's not a good term there for it, because those choices on the labor complement will be there, but they are a separate activity. So okay, let me and you'll see how it's handled here. Okay, so we have, just as we'd expect, C, S, and W are the variables, the choice variables. Z is the objective, and here are those net revenue. So you take the price times yield, subtract off the dollar costs that we had, and these are the objective coefficients for the three cropping activities. And then the last one, so we said that we were going to leave the hiring of labor costs out of these, and it's true, we are, because over here we're going to have a higher labor activity, HL, and it's going to enter the objective equation with a negative, right? So it's a negative $6. If you need a labor unit, you get it by changing this variable to 1, and then you lower the objective equation by $6. Okay, so we add that to the objective equation here, and then we need to figure out how to get it into the model elsewhere. This is the land constraint, the first constraint, so it just says add up your corn, soybean, and wheat, planted, harvested, whatever you want to call it. That needs to be less than 600 units, or 600 acres. These are the requirements of labor. So each unit of corn, each acre of corn requires 3 hours. For soybeans it's 2.5, and for wheat it's 2.4. Okay, and so that's the usage rates of labor. And the right hand side here is 1,700 units of labor. That is the family labor complement. So pretend that the hired labor is not there for right now, and we would say that we're constrained to produce based on 600 units, 600 acres, and 1,700 hours of labor, and that's what we would get. But when we bring in the ability to hire labor, it is like saying, put it on this side of the equation and it's subtracted. It's like adding, every time we hire a unit of labor, it's like adding 1 to the right hand side here. So if you hire 10 units of labor, you're taking $60 away from the objective equation, but you're adding 10 units to the right hand side here, so you're expanding the ability to produce. And so obviously the question for the model then is that 10 units that cost $60 up here going to allow us to expand enough production so that we want to do that? Okay, we can't hire labor indefinitely, so there are 900 hours available of hired labor, and so we can deal with that with a separate constraint that just says that variable can never go above a level of 900. And then of course down here we have our non-negativity constraints, which I don't know why they say those units are acres. They are both acres and hours. Okay, so The key assumption, though, here, the price that we include for hired labor of the addition of this additional activity, the price for hired labor, and the idea that there is this 900 hours, and it doesn't matter where we want to use it, we can. And then, of course, the big one is that it directly substitutes for family labor. Do we believe that to be the case? Is there, is this labor complement, the 1,700 hours that are being required, sort of low skill or low training labor, so that there's no investment or no sort of skill requirement training to make the hired labor the equivalent of the family labor, which is often an issue, right? So there, it may not take a lot, but there may be a productivity drop, so that you have to hire 1.1 or 1.05 hours of outside labor to overcome sort of the learned or effective skill development of someone who lives on a farm and worked it for several years and knows all the procedures. Okay, so we have this pretty simple model. It's aggregate. It includes every activity that we're going to consider on the production side. And so we would think about what are the advantages, what are the disadvantages. Well, this aggregate model, this is one that we could easily solve by hand. We can find the solution, and we should be able to trace values quite nicely. But from if we do hire labor, we should be able to look at the labor coefficients here and move to what are the choice activities up here that are in the model, and think about what sort of expansionary effect is there on this, and then of course think about how sensitive labor hiring is to the price we chose, and we will do that first. What are the disadvantages? Well, this net return of corn has a yield and a price assumption, and right now we can't split those up. And so it turns out when revenue adjusts in crops, it is either because the market is moving or the yield is higher or lower than expected. And oftentimes those things both happen. So there's no sensitivity that we can do right now on the corn price, saying what if the corn price is 15% higher and our yield is the same. If we expect that price bump, if there's a forecast in there for the price to increase, we either have to figure out what that means for this coefficient, which means rewriting this, but there's no way to think about the sensitivity information that we would get, the allowable increase or decrease, without doing extra calculations to see how much of that would be yield related versus price related. And we would still have to pick one or the other. Okay, so I think I have this model set up, so let me switch to a spreadsheet. Okay, so yeah, you can just build this, I guess. I don't know. Probably for the best, because I'm going to be, as we go through here, I'm going to be making changes to this spreadsheet to get us to the more disaggregate version and the final one that you'll need. So yeah, maybe what I'll do is I'll just post this one and you can start from this. So look for a spreadsheet. It should look like this, and check it, so you should check the formulas. And so this left-hand side is the activity levels, right? B3 to E3 multiplied by these coefficients. So that looks good. And up here is the objective. So the per unit returns of the objective coefficients times the activity levels. Yeah, so we have this basic model set up. And there's nothing to do but to solve it. So I think I have it all set up in Solver. If we run that, we get this. So I believe if you look in the book, it gives the solution here. something like this. So 354.7, 245. So we're using 600 acres, right? And you can see that down here that it's binding. We're using 1,700 hours of family labor, and we are not hiring any labor. Okay, so that's our first solution. We didn't hire labor, and that might be the question that we have is what is it about the current setup and the required labor usage and the price of labor that is causing us not to do this, not to incorporate that in our solution. And you should have an answer for it right away, and it should be that when we go and look, before we look at any sensitivity, when we go and look at the right-hand side of this family labor, that's what I'm calling that, the family labor constraint, the shadow price is going to be less than $6. If it were higher than $6, then we would want to invoke this activity, increase this right-hand side, and expand production. Okay, so we don't know exactly what it is, but we know it's less than $6. So let's switch back over to the model solution in terms of, I've got just the sensitivity report up here, and you can see that was the one thing we knew was that the family labor is going to be under $6, and it turns out it's way below $6. It's 42 cents. Okay, that's per hour, right? So this is the final value, the right-hand side, a binding constraint, and we're getting 42 cents for that last unit. And that unit is not just for the 1,700, the last one, but it's for the 170 units before that. So that's 170 units earning about 40 cents on the dollar. So, $70 for 170 hours. That brings my next question. If people coming to our farm and saying we will work for you for $6 an hour are getting $6 an hour somewhere, if that is the market rate, then should we on the family farm be going out with them or to the same places they go and evidently get hired sometimes and say, hey, we would work for anything above 42 cents because that is better for us, okay? And so that is probably not the realistic question we want to think about, but we are going to think about what would it take, or what would we do, would we like to sell our labor? And that's going to be the off-farm question. Off-farm work question is going to be the one we think about. Okay, so we got the other sensitivity information that's interesting here. I think you can trace all of these through some combination of the change in the returns and the use of labor. So you know what the value of labor is 42. So obviously the reduced cost here is if you force me to hire labor, then the return change is $5.58. Well, $5.58 plus 42 cents is $6. Okay, and so the allowable increase in the reduced cost match up here, and then 2024 from the wheat activity. Well, the difference here is 20 and a half. So we would have to count for the other 26 cents. And it's going to be in the differential usage of labor. Okay, so what is the requirement of using labor by corn versus wheat, or whichever one of these is the marginal crop? Corn uses more labor. So switching to wheat would save you some labor. So if you got to get these proportional means one, getting more on the return side, and a little bit of savings on labor costs. So that would be how you would try to work through that and explain it in terms of those numbers. We're going to spend a lot of time on it, but that is one of the questions at the end here, trying to figure out how do you look at the sort of opportunity cost numbers here, not just in flat terms, just saying, this needs to go up by 2024 for it to be competitive, but think about what components in the model are causing that to be 2024, because it is not just the case that it is 171 minus 150.5. Okay. Yeah, so I snipped out of the book here the optimal solution to the problem. You can see they reported everything that we have been asking to report, the activity levels, and then the constraint effects they report as, the constraint status they report as slack variables, which is fine, and then the objective variable. And then here they put the shadow prices for the binding constraints. The marginal return to labor at 41 cents, the cost of labor $6. So that's my question. Should we be selling labor that's owned by the farm? We are endowed with it. We are choosing to put it to put it towards the farm business. Should we be putting it somewhere else? How would we change the model to incorporate that, selling off the farm labor? Yeah, so let's look at what it takes to add an activity to sell labor. We have the hired labor activity right here, so right next to it we would need something, a variable, maybe call it LS, labor sold from the family's endowment to the market. How do we change the objective equation? Well, that would go up here, LS, up in the objective equation, and it would need a positive coefficient in front of it, because we are actually going to generate returns. We're going to put our labor in another activity, that a selling activity, to the market, and we would generate positive returns for that. How do we change the constraints? Well, when we sell our labor to the market, it is no longer part of, it draws just the same as, like, we're selling our labor to the corn activity. So when the corn activity is 1 unit, that means it draws 3.03 away from the total. When we produce an acre of soybeans, it draws 2.55 from the total. When we sell a unit of labor to the market, it draws 1 unit away from this total. And so that's the constraint we need. And then we would need a labor non-negativity constraint. So let's think about what that looks like. And we have to ask ourselves, what is the opportunity cost of labor? So we can do a not very serious model where we just said, let's just make sure that the price for farm labor being sold to the market is above 41 cents, because we know that's the opportunity cost currently in place. And we know it will change the solution, but it's not very interesting. So we should think about what determines labor market offers. So is it true that we are, this family labor is completely defined by the ability to work on the farm? Well, it's probably not. So there are all kinds of things that go into a job wage offer. Certainly education and experience, location, mobility, right? So all of those kind of things. And so with that in mind, the idea that there's probably going to stay attached to the farm business location terms, there's probably not a lot of mobility, but there could be a lot of flexibility on hours. And so I'm not going to just be bound to the idea that let's just make it competitive so that we want to sell labor and see what the result changes to. I want to give a real number, and so I think I'm going to end up putting in $10 when we add it. And that is correct. That is what I added. So this is the new model. We said we needed to make a change to the objective equation, and we do. All right, so we add the activity here in this cell. We add the price that we're willing to take, $10. And then we add the draw, right? The usage, or the sort of demand, the activity demand on family labor to be 1 unit for every unit we sell to the market. Okay, so we should think about that. The implications immediately are that, $10, if we can sell our labor at that value, then we know we're going to be selling labor, right? Um, we don't know a lot beyond that, and we should solve a model before we start talking about it too deeply. But we could play around with the idea that if we can hire labor at $6 and sell it at $10, then as long as we're perfect substitutes for each other, as long as they do what we do, and this equation right here says that is what happens. The 3.03 from this right hand side, the negative one and the positive one here, that is saying that take an hour away from the farm owned part or the family part, bring one in from the outside, and you're back to square one. So this 10 being larger than this 6 cost means that you're going to be hiring some labor in the new model. Okay, so it's not going to be a case of just drawing down production. You are going to be replacing family labor, and we'll see how much. And then we should ask: is this model set up correct? And so I'm going to pull up the spreadsheet, and we'll actually build this setup just so that we can see it, see the changes, and so you can follow along in the spreadsheet I gave you and add this iteration to the model. Okay, I'm going to try something here that I usually, well, first of all, I guess just while I've got this up, let me just mention I'm doing this in a spreadsheet because I think for demonstration purposes, they are just, and as long as they're not larger than one page, for linear programming models, I think they're the way to build models. And then, we've already seen that if I build the model here, of course, I can see all the equations and how they work, and then I could build it here. If I have it consistent, I can easily write down the algebraic form and then write the code for it, and then we can use big pieces of this spreadsheet to set up the data reads into GAMs, and then if we needed to do some parametric programming or whatever, basically have two versions of it maintained. But yeah, for these demonstrations, I'm going to use this. And so let me look at the solver here, and so you can see that solver is looking for looking at the constraints F5 to F7, H5 to H7, and then the activities from B to E. Okay, so let's close that, and then I want to try something here. I want to insert so highlight column E, right click, and then hit insert. And now when I look at solver, it is looking at B through F, right? That B colon F means that everything between those two is going to be an objective equation. And then it shifted G compared with I. And so what happened by inserting there to the left of an already established activity and not inserting to the right of it, it means that my solver parameters are going to be okay. They're going to expand because I'm using this range, and because the endpoint of the range got moved over, solver said, okay, then you probably want that to be part of your model too, and the same thing here. But I really want that to be over where it was, so I'm going to click, highlight that information, hit Control, whoops, I don't know what that was, hit Control X to cut it, and then I'm just going to hit Control V to paste it, and now I'm going to have my labor selling activity here. And hopefully that will be, oh, I don't know what that was there, delete. Yeah, I'm getting some odd inputs here. So 10 and 0, and then on our sheet we had 0, 1, and 0. Okay, so this is going to draw on family labor. Now what do we have here? Well, it turns out these did not fix for us, right? So the B to E sum product formulas did not work, so we got to fix those. And if you notice, these little arrows in the corner popped up, basically saying the formula that's here now is probably not what you want. It's the warning. Right, so it's saying there's a formula here that's using adjacent cells, but it's not got all of the adjacent cells. It would be nice if they said, do you want it to include all those? But it doesn't. So that means you got to track through here, and what I typically do is just, now I want it to be F, so I just edit the E and make it an F. That made that little arrow go away, and then just paste, drag it down, and it'll cut and paste, copy paste automatically. We got another little arrow up here. It's only going to count the revenue from E, and so let's change that. We need an F there and an F there. Okay, so it's not perfect, but it worked. It worked out, and now solver is ready, and it's going to compare G to I, which is what we want, and it's going to use B through. Oh, it didn't change that. It changed it back. Okay, so we're going to need to change that too. B through F, and run our model. Okay, so maybe inserting, cutting, and pasting isn't so great, yeah, but for some reason it used to be better than that, I think. Anyway, so we run it, we get a solution. Can we believe it, or do we think it's working? Well, that is a completely valid question. What did we do? What do we have now? We said we predicted that we were going to start selling labor because the shadow price was 42 cents, and now we're saying you could sell it for $10, so we do, and we sell a lot of it. And we also said that something is going to happen on the farm. Probably the case, we're going to sell labor and sell a bunch of it because we can get $10 for it and then replace the labor we're using on the farm with hired labor. We still plant 600 acres of crops. Okay, so I believe the PowerPoint now is where we go back, and we'll see the results on the next slide. So if you look here, so we had the original value compared to the new solution. So about $5,229 compared to the base model. We use all 600 acres. Every bit of labor available to this model is used. How much labor does soybean production use? And then the other change here is we go from this split of corn and soybean production to only producing soybeans. So we went from being a mixed production farm to producing just soybeans. And we can say how much labor does soybean production use, since it's only this one. 2.55 times 600 acres is how much production we have. That's 1,530. So we're going to hire 900 hours to use in soybean production. That leaves us 630 hours of family labor that we, if we're going to use all of our land, we need to draw 630 hours from the family labor pool, and then the rest of the family labor we're going to sell to the market, and that's where you get these numbers from. So 1,700 total. We're going to sell 1,070, and 630 are going to be drawn into soybean production. And then, so at this point, we can say a few things. It must be the case that soybean production in this model is getting us some decent returns on family labor, right? Combined, either the value of leaving so it's complicated because it's bound up in the value of land, right? Because leaving land idle, land had a large shadow price, so we're going to tend to use all of the land, and that means drawing in labor, even if the labor is more valuable on a per unit basis, sold off the farm, it is not the case that leaving the land idle is valuable. Okay, so the balance. They're connected. Input use is something we have to talk our way through and think about. So when you think about those high marginal values on land that we had in the first one, those are going to govern the resource use of land, both land and labor in some context. So we should ask ourselves what the shadow price of labor will be. Well, we can make the case here that we first use, this is a simultaneous model, but we can make the case that the way this worked is we hired as much labor as we could. We put it into soybean production. We were 630 hours short. We pulled family labor there, and then we started selling off the rest of it. Okay, we tried to get as much family labor. We did get as much family labor out of the soybean activity as possible. We were still left with 630, and then the rest of it went straight to the market. And so the shadow price of labor, well, it's probably going to be $10, right? If we had another hour available, we know that we would just sell it to the market because we're tapped out. We used all of our land. If we had more land, then we would have a complex solution, right? We have two things moving at once. What would we do with the labor? Well, we would probably draw in more labor, right, and produce a higher net return. But if we just, on a one-off, just added one to the right-hand side somewhere on labor, then we would sell it to the market. Okay, so if we move through the sensitivity report on this new model, we have here the results. These reduced cost values tell us that $4.60, $18.80, that's if you force me to produce a unit of corn, an acre of corn, then $4.60 is how much the objective equation would drop. And for wheat, that's $18.80 per acre. The shadow prices are what we expected, so this one's $10, saying if you give me another hour of family labor, I'm selling that to the market. If you give another available, right, if there's somehow the person that we're hiring says, you know what, I've got an extra 10 hours that I will work for you, then we would say, okay, we will hire you. We would pay $60 for that, and that would free up labor of the family, right, to sell to the market. And so the shadow price, there's $4 because hiring people means that we can work more off the farm. Right now, the marginal value on land is $145.30, so land is sort of controlling the solution and saying you have got to use all the land because it has this high marginal return, right, embedded in these crop activities. But as part of that, you are required to use some labor, whether it's family or hired labor. And so the mechanism by which we can sell more labor to the market means hiring more, right? So we're paying $6 to get the right-hand side adjusted on the higher labor constraint, which lets us substitute, and so that's where you get this net shadow price value of $4. So in some way, the labor in this model, though, we know we're going to use all the land, has the high shadow price, but in some ways, the labor is driving the model. So it must be the case that we take these coefficients here, the objective coefficient, the sort of net revenue above the variable cost items, right, that are just per acre items, take that, then look at the usage rate of labor in the model and calculate that, and that is what's going to drive this shadow price. So the fact that we're choosing soybeans over corn, they have essentially the same, this would Excel or any model would care that there's 20 cents per acre difference here, but that numerically those are close to the same. What isn't the same is every acre that you commit to this versus this, you're using a half of an hour more of labor if you try to produce corn. So soybean is the labor conserving activity. Labor now has this other outlet to sell to the market, and that's why we've switched to soybeans. So we have a model here where the land returns are sort of driving some of the labor, but the labor coefficients, right, and the ability to sell labor is driving the activity choice, right? So we know we're going to use all the land, but how we use it is really being determined by, one, the objective coefficient, the sort of net revenue side, and then comparing it to the labor coefficient. Yeah, and so if you looked here, the return per hour of labor used goes from soybean at 67 down to corn at 56.4. So that's part of the story, right? It ignores some other pieces that we would see, right? But that tells us that the advantage is not just this 20 cents negative, it is actually bound up in this as well. And then, of course, for wheat, the objective coefficient divided by labor usage rate is high, but it's not high enough compared to this that it can overcome the low starting value, right? So it's $20 deficient. And you can see that right here in the shadow prices. So it's actually $14.20 worse, accounting for the labor requirements. The activity choices, we know the marginal value of family labor is $10, so we could actually just calculate a new set of net returns, right? So since that we're bound up on hiring labor, right? We've hired everything we can. We could sell labor at $10, so we could just put it in as a charge and make new objective coefficients for comparison, just like we might in a tableau, and this is what we would get. So if you take $10 times the family labor coefficient, here's the new comparison, the relevant comparison. So 145.3, 140.7, and 126.5. Okay, and so these are the effective net returns in this model where we have solved out the family labor price to be $10. So if we took soybeans out of the model, we could use this to be a new predictor on what we would choose, and of course it lines up exactly with the shadow price over here, 460 versus 1880. Okay, so all that can be very important for us, especially if we thought the net returns in corn versus soybean were about to diverge. Is there a trade war? Are soybean returns about to fall? Do we start shifting to corn, and when? We can find that. But how do we explain it? Okay, so I just zeroed out soybeans here, resolved the model, and we do see that it all shifts to corn. Okay, so you don't have to do that solution, but if you want to, go ahead. I think just take the activity out of the model and it'll work for soybeans. So that model's working, and that's good, but it also is incorrect. And so we should acknowledge that and see if we can figure out why. So if I tell you it's incorrect, or if I tell you it's got a problem, I owe it to you, I guess, to go back and see if I can tell you why I know there was a problem. And it's in these two things right here. This is telling me that I can hire, or that the shadow value on family labor is $10, the shadow value on hired labor is $4, and the allowable increase for these two is infinite. That is a signal that something is up here. Okay, so why would I ever hire more labor than it takes to make the crop? Right? So we know, we did the calculations somewhere here. We know that right now we're using 1,530 total hours of labor, 900 that we hire, 630 that we're drawing from the family. And we know that we would like to pay someone $6 and then go make $10 with our labor, right? So we have this effect that we are more valuable on the market than they are for some reason. And so having them replace us on our own farm at $6 an hour is valuable to us. But this is saying keep doing it. This is saying hire more than that, and that makes no sense. And the computer didn't mess up. We have a problem in what we gave it to work with. And it comes from this constraint right here, which says on this, and we can test for it. And let me show you the test. So the model's working. Is it correct? Well, I'm upset that I saw that infinite right hand side for hiring labor, and so let's just double it. Oh, that's incorrect. That's not supposed to be 19. It's 1700. Sorry about that. That slide is incorrect. Okay. Yeah. So 1,700 hours of family labor, 1,970 hours labor sold to the market for $10. So what is going on here is our model in this new solution is saying, hire every hour you can get. Yeah, make your crop. That's fine. Plant all 600 acres. But then just hire people, and when you go sell your labor to the market, go take them to the market with you, and take the extra $4 that you can get by selling their labor. And that's not something that we want to think about, right? That's not something that makes any sense. If we were putting together a labor crew, then maybe we would think about, but we would have to account for the $4 difference, right? Because it would have to be for us providing some kind of differentiated labor. Right now it's saying that we give the same labor they do to someone else, right? So it's believable that we can earn more, but this is like some kind of fake thing where someone working with us is more valuable, right? Because we're the manager or whatever, and that may be the case, that we're putting together a contract labor crew or something. We'd have to be much more explicit, because what we're getting right now is just something that's handing us free money by hiring someone and saying, well, today you're not going to work here, we're going to take you with us and work somewhere else, and they'll never figure out that we're getting $10 for every hour they work. Not a realistic activity set. So what we need to do is de-link the family and hired labor. The fact that we're charging $10 here and $6 is their charge in the market, because we're in the market, right? We're in the market for hired labor as well, is a signal that we need to link these up. So something about their labor is a good substitute for our labor on the farm, but not a good substitute out in the market, okay? And that's completely believable, because we're the family labor. We know what we were being undervalued on the farm at $10. If $10 is what we can earn in the market, because the shadow value originally was like 40 cents. And so that's what we're going to play with. Rule of thumb, if you have a homogeneous product, right, so something that is, you don't differentiate, and you have a buy activity and a sell activity for it, then you need to make the cost to your operation be larger than the price that you sell it at in a linear model, right? So that's one way of turning it off, is just being sure that anytime you sell labor, it is at a lower return than you can pay for it. Well, that doesn't fit our family labor versus hired labor case, because we believe the product isn't homogeneous. But if you were going to treat it that way, like I want to buy hay, that's the classic one. I want to buy some kind of feed product or hay to feed on my farm, or I'm going to produce hay to feed to my animals, or I'm going to produce hay and sell. Well, then you usually have to give yourself some kind of discount when you sell it versus buy it. Otherwise, the farm will forget about production and just buy a bunch of hay and then resell it for a little bit more. Okay, so what do you do? Well, if you don't fix these prices for the homogeneous product, you get this fake arbitrage, right, where you just keep buying and reselling things because nobody can figure out what you figured out, that there's a better price out there. The second delinking option is the one I'm going to produce here in this in our final version, and that you're going to work from for your and we're going to talk through on class a little bit on Thursday. So the second option here is we have reasonably the family labor endowment may command more on the market than the hired farm labor rate. Okay, so we for some reason we believe that we're getting better offers from the market than the labor that we hire would, and our choice to work on the farm is really more of a location and sort of a convenience fee, right? So the idea that we're already there managing the farm means we're going to spend a certain number of hours there, and so you're going to have to pay us a premium to leave the farm and work, and because we are going to have to pay someone to come in and replace the component of our family labor that is equivalent to hired labor. So we need that expanded setup, and so what we can do is think about it this way. Corn, soybean, wheat can all demand labor of either type for use, okay? But the market the marketing of labor is only allowed for family labor. So we can only have a demand in the market at $10 for the family labor endowment. So if you think about this as a sort of allocation problem, the family labor endowment can go to corn, soybean, wheat, or to the market. The hired labor endowment is purchased from the market at $6, and then once we've sort of got our component or our complement of hired labor here, we can allocate that to wheat, soybean, or corn. So the key part is we need that these are substitutes in these three activities, right? We're going to say that they're good substitutes in those three activities because the hired labor is as effective as you can get, and so putting the family labor there, even if they are more, have a higher market value, they can't get any better than that return. So they would go to the market and look for the higher return. Okay, so how do we do that? Well, we need a model with two labor types. A family labor supply that can sell to the market at $10 per hour or sell to the farm at $0 per hour. That's an implicit cost of $10 per hour because there's an alternative activity that says $10. So if production will generate greater than $10 per hour, then the supply will go to the farm. If not, it won't. But we're not going to make an explicit charge because the constraint binding is always going to do that. So we got a family labor supply, then we need a total labor equation, farm production labor demand. So the corn, soybean, and wheat draw their labor from this total labor equation. Every hour used in that total labor availability equation is going to be either hired labor or family labor. And so in this way we can get family labor and hired labor to still be perfect substitutes on the farm, but they're not perfect substitutes in the market in general. Alright, so what does that look like? Well, this is the setup, and you're going to need to expand the model you have and add these two and add these activities and the equations. So we run this. Let me talk you through it here. Yeah. So what do we have? Well, we have the same objective coefficients. We have a labor hiring activity, a $6 cost. Labor supply to the business, we make no charge. We hand it over directly. And then labor supply to the market, we generate a $10 return. Okay? But this $10 is going to govern the effective cost of any labor supplied to the business. So it sets the opportunity cost. It sets the wage rate. When soybean activities come in, they are going to be paying $10 for this. Okay? And so what do we get? The land constraint looks the same. The family labor constraint now says that when you sell labor to the business, draw 1 hour from the 1700. When you sell labor to the market, draw 1 hour from the 1700. But this thing is now fixed. There's no way to augment the family labor complement. Hired labor is stuck down here, and it says if you hire an hour of labor, you get an hour of labor to use. It costs you $6, and right now the limit on hiring labor is at 900 hours. All right, so the person that we're looking to bring on the farm only has 900 hours available. And then what do we do? Well, both of these supply, right? This is a supply of labor, this one, to the farm for use in these productive activities. This one is a supply of labor to the farm for use in these productive activities over here. And so they just both get -1s down here. So if you hire an hour of labor or you supply or sell an hour of labor to the business, family labor, then they both show up down here with -1s. Okay, and that's going to be your supply side. So these negative ones are like plus ones on the right hand side. So every hour hired, every hour sold of family labor to the business goes on the right hand side here. So it's 900 plus 1630, it's 1530 on this side, or negative 1530 combined right here. And then you put the labor demands of the farm in this same equation. So this is effectively the farm labor demand equation, or the total labor equation I put, because I want it's the equilibrium equation, the supply demand equation. Labor supply, labor demand has to balance out because it's a transfer type row to be 0. Okay. So we've got the new model, the new solution. It's the same solution that we had back before we doubled the right hand side, right? 600 hour, oops, not that one, right here. 600 acres of soybean. This is the reduced cost. These are the shadow prices. So we should be able to find that the new solution is a lot like those, because it's the same objective variable, same amount of labor sold to the market, same amount of hired labor. So it should all line up. If we wanted to confirm it the same way we did before, we could say, what if hiring of labor doubled to 1,800 allowed? Well, now we cap it. There's nothing for us to do with hired labor except use it on the farm, and we would be happy to hire every bit of labor used on our farm at $6. And so, but the key part here is that no longer are we in the business of, hey, we'll just keep hiring you and then sell you at $10, sell your labor at $10 per hour. Okay, so I want you to not that one. Sorry. I want you to set this up, get the solution for it. It should be the same, so you should be able to look at the shadow values and so forth, and see that you get exactly the same solution: 600, 900, 630, 1070, and then this number. And then I want you to prepare for the next class this part A and part B here. We'll do it all on the board as a class, but I'll ask you to provide the information. So one, just write the algebraic form of the model, the final model, and then be prepared if I call for you to give me an explanation for that final transfer equation on total labor. And then the next part, if the farm could expand by renting land, right, that is of lower quality than the land the farm currently operates. So let's say that the farm has some really good land at 600 acres that's there. How would you get some differentiated land that isn't as good as what we have? What kind of information would you need? How would you add it to the model in terms of variables and equations? So just think about that as rental land, and how you would get that in there, and how you would think about the crop planting mix and how it works in this model. I haven't done that yet, so if you think the question here is not asking exactly what you want, when it says variables and equations, just work from your own assumptions. I mean, because there's also data you're going to need on prices, the rental price, and we're just trying to look at how will we keep expanding this model. And so take the land equivalent of what we've done with labor and see if you can build that. And the second part is looking at the sensitivity. So you've got the final version of the model. I want you to be prepared to look at the reduced cost for the corn activity. It's negative $4.80 per unit. Can you explain that in terms of the model parameters? And specifically, I want that number explained in terms of the labor usage rate and objective coefficients. Okay, so remember, corn is 0 in the final solution. $4.80 is the penalty we would take on per acre of growing corn when we shouldn't, or when it's not best. And so I believe there's an explanation in terms of the labor usage and objective coefficients you can get. And then the other one is the shadow price on hired labor is $4. Is that a willingness to pay for an extra unit of hired labor? And that is the tradition, right? That is what we've said in your midterm just recently. We said, what is the willingness to pay for whatever? Does that answer that question in this model we have right now? And so I guess my hint to you would be solve the model with the right-hand side of labor at 901, and then think about does or doesn't this comply with that willingness to pay interpretation. And if it doesn't, why doesn't it? Okay? And so, I mean, the hint is all you need, I guess, but you'll be able to see that when you have these type of constraints that interact with each other, it's not always the case that you can just say this is the willingness to pay for an additional unit. Okay, so work with that. Again, I'll give you a starting spreadsheet, but you'll need to build it out to this level, make sure that it solves, just for my own satisfaction that we can all do that. And then on Thursday, we'll start class right from this, and when we feel good about how we've sort of looked through this part, we'll move on to building out the stages of production model, so that we can think about parametric programming on things like yield and price assumptions. So thanks for your attention, and you've got your work prepared here for you.